Hello guys, this video is going to be about how to solve RL circuits. Now I'm not going to make a lot of videos about RL circuits because it's not that different from RC circuits. So the equation that we need to use comes in this form, and this is the only equation that we need to memorize when solving RL circuits. So to use this equation, the first value that we need to find is I of infinity. Now this is the current flowing through this point when time goes to infinity. Now if you look at the circuit, this is when switch is open. So we don't need to consider this part of circuit because this is an open circuit. So the circuit that we can redraw looks like this. Now if you see here, I replaced an inductor as a wire because inductors in the DC signal works as a short circuit. And since current flowing from this voltage source has a direct path to this part of circuit, we don't need to consider this part because current would never flow through here. So by using a simple Ohm's law, we can get the value of I of t, which is minus 2 milliamps. And now this is minus 2 milliamps because we have a plus sign in this position. So since current flows out of plus sign, we can see that this is in opposite position. So that's why I wrote minus 2 milliamps instead of 2 milliamps. Now the next value that we need to find is I of 0. Now this in fact is I of 0 plus. Now this means the moment just after the switch is open. But in this case, it is same as I of 0 minus because current flowing through an inductor cannot change instantly. And since this equation is always true, let's find the value of I of 0 minus. And to find the value of I of 0 minus, we can use superposition theorem because we have two voltage sources. And the two circuits that we can draw comes in this form. And if you see these two circuits, you can see that I did not draw this part of circuit because current would never flow through here because it has a direct current path. And the same thing goes for these two part of circuit because we have a direct current path. So by using a simple Ohm's law, we can get the value which is 6 milliamps and 2 milliamps. Actually minus 2 milliamps because we have a current flowing through this direction. So by using superposition theorem, we can add these two values up and we get 4 milliamps as our answer. The last thing we need to find is the value of tau, which is L over R. Now this R is in fact Thevenin resistance. So in order to find this Thevenin resistance, we can redraw the circuit in this way. Now if you look at this circuit, we are trying to find the Thevenin resistance, so I short-circuited the voltage sources. Now an important thing to note about this circuit is that I was trying to find the value of Thevenin resistance just right after the switch is open. Now I wrote T to be 0 plus, not 0 minus, because this tau, which means a time constant, is about how fast a current going through this inductor can change. If you look at this circuit, you can see that these resistors are in parallel. So the Thevenin resistance measured from this point, which is this point, is equal to 6 over 5 kilo ohms. So tau in our case would be this value. So if you plug all these values in, the final answer that we get comes in this form.